Hello everyone. From this video series we are going to discuss grade 10 and grade 11 maths lessons in your textbooks. Uh, but we are only discussing a summary of the theory, and we are specially paying our attention on the miscellaneous problems at the end of the lesson. Through those problems we can get a good idea about the whole lesson in our textbook. So if you have any concern about theory or any explanation, you can comment, then we can put some small video clips related to those lessons. So in this first video we are going to discuss the first lesson in the grade 10 textbook, that is perimeter. So we know the perimeter is the path surrounded by a two-dimensional shape. So these are the simple shapes that we learned in our earlier grades. Rectangle, we know the perimeter of the rectangle is uh, length plus breadth into 2, and square is a special kind of rectangle where the length equal to the breadth. So we can get the perimeter of a square by multiplying length of a side by 4. And triangle, the sum of the lengths of the three sides are the length of the triangle, perimeter of the triangle. And circle is a special kind of shape. So in this case the perimeter of, so we know pi, the value of the pi is 22 by 7. So those are the main shapes we learned in our previous grades, and there's a review exercise for that. So we can see these all are very simple questions. First one, we can get length plus breadth into 2. So length plus breadth 30 into 2, 60 centimeter. And this is a square. We know length of a side into 4. So 7 into 4 is 28 centimeter. So the triangle, all the sides of the triangle are equal. So the perimeter should be 12 into 3, 36. So these are the simple shapes, and the 4, it's also a simple shape but in a different way. So here we are talking about the perimeter. So we can move this side into here and then this side into there. So we can get a simple rectangle there. So the length is 12 and the breadth is 8. So 12 plus 8, 20, 20 into 2, 40 centimeter. So these measurements, there's no need of these measurements. These are only valid if we are going to get the area of the shape. So this is also very simple. And here also this is also a very simple case where we can move this part here and this part there, and we can get a square. So 10 into 4, 40 centimeter. This is a circle. So circle we know 2 pi into radius. Radius is 7. So 44 centimeter. So this is very easy question. And then there's some sort of complex shape where we have to use another theory we learned in our previous grades, that is the Pythagoras theorem. We know we have to get the length of this part. For that we know 3 squared plus 4 squared is equal to the square root of that equal to the length of this part. So that is 5 centimeter. And 5, and we know this is 6 and this is 3, and this whole part, you know, this is equal to 10 centimeter, and here it equals to this, these two are, it says these two parts are equal. So this is 3 and this is 3. So from that we can easily calculate 5 plus 6, 11 plus 3, 14, and then 10, 24 and 27. So this is the whole perimeter is 27 centimeters. So it is very easy part. And then there's another NIV theory, that is sect of a circle. So this is a whole circle, and if we get a part of that circle, we say it is an arc. So sector mean arc plus the two radius. So a portion of a circle with a center which is bounded by the two radius, that is we called a sector. So this theta value we call, that is the angle at the center. So these are the new words we learned: sector and the angle at the center. We have to use these words when we are calculating a perimeter of a circle or part of a circle. So we know the angle of the center can take 0 to 360. See, we know the angle around a point is 360. So for a circle, it can take 0 to 360. And these are some simple things. I don't think we need to go through that. So we have to find the arc length of a sector. So when we are going to find the perimeter of a sector, we have to first calculate the arc length, and then we have to add two radius. So this is some sort of very easy we have to go through a very easy calculation. We know the whole circumference of the circumference of the circle is 360. So the arc length is proportional to the theta value or the angle at the center. So for a circle, the angle of the center is 360, and for a specific arc length, it is theta. So if the perimeter or the circumference of a circle is 2 pi r, that is for 360. So what is the arc length for a theta value? We have to divide 2 pi r by 360 and multiply by theta. So from that we can get arc length. I think it's clear for you. For a circumference or for a whole circle, it's 2 pi r, and angle at the center for a circle is 360. But for a specific arc sector, the angle at the center is theta. So for 360, it is 2 pi r. So then what is the value for theta? So very simple calculation. So we can get the arc length by that. And then for the sector, the perimeter of the sector, we have to add arc length plus 2 radius, that is 2 pi r theta over 360 plus 2r. So that is the perimeter of a circle. So this is a summary of that. And then there's another example for that. I think there's no need of going through that because they have explained that well. And then there's an exercise also. This exercise also they have asked to find the arc length of the each sector. So they are only asking about the arc length, not the perimeter of the sector. So for the first one, we can see the angle at the center is 180. That is a half of a full circle. So 2 pi r over 2 or 2 pi r theta is 1. Then the next part is find the perimeter of a sector of a circle. So as we discussed, we can get the arc length by 2 pi r into third theta over 360, and then for a sector we know we have to add 2 more radius values. So then we can get the perimeter of a sector by this equation given in the textbook. And there are some examples for that calculation. So these are very simple examples where in the first one you can see the sector angle at the center of this sector is 120, and we can calculate the arc length by 2 pi r multiplying by the 120 over 360, and then we have to add 2 into radius, that is 21 into 2. So we can get the sector perimeter by adding these two values. Second one also a very simple question, and then we can see the exercise. The same simple questions are there. They have asked to find the arc length of the sector like that, and then the perimeter of a plane figure containing the sectors. So some combined shapes where you can see a sector and some other shapes we learned in previous grades. So here in these cases we have to pay our attention. First we have to go through the path or through the perimeter of the shape. So we can see what are the sides we have to use in our calculations and what are the sides we have to left or in our calculation. So in the first example we can see as one side of a breadth of the rectangle we do not need to use in our calculation, and we only need to add the arc length in the sector. So we have to add 2 lengths plus 1 breadth of the rectangle and then the part of the circle. Second example, it's also a very simple one. Here it contains several shapes where we can calculate the GF value by the Pythagoras theorem, that is 10 centimeters, well known values, and then BG we can calculate 2 pi r. The angle at the center is 90 over 360, and then we can get the BG length. And BC length we know AB is we can get the AB value be equal to AG. So AG we can get the CD is 15, and we have to 15 minus 8, then we can get 7 centimeters. So AB is 7 and BC length is so then we can get CD value. FD in the same way, AC is 15, so EF is 6, then we can get FD value. So from that, so now we know all the parts of the our shape, then we can calculate the perimeter by simply adding them. And there are some simple questions so in the exercise also. First one is same as the example, and the second one we can see a triangle and a sector. The triangle, the two sides of the triangle are equal, so 4 plus 4, and the arc length of a semicircle. In the second question also a very simple one, and we can prove some theory also, but in this question they have not paid they are not using this question to prove that theory. So just we have to calculate the arc length of the sector of the circle with radius 7 and diameter 7. And then the third one also very simple one. Here they say it is an equilateral triangle. So the angle of the center of AC ACB sector should be 60 degrees. So we can calculate the AC arc length through that. 2 pi r 60 over 360, and then we can get the AC, and we have to add AC side of the triangle. Then we can get the perimeter of the shaded region. And fourth one also very simple one. There it contains two sectors having the angle at the center equal to 90 degrees. So simply a half a circle. We have to calculate the perimeter of a half a circle. And the fifth one also very simple, same things. So I don't think we need to discuss that. The miscellaneous exercises, the first one. In the first one we can see here it is for calculate the perimeter we have to get the arc length, that is 2 pi r theta. Theta is 360 minus 120, that is 240, and then plus 2r. R is 21, so we can get simply that is 130. Then the second question. The second question is a combined shape, and in these problems we can dismantle this shape. We can see this combined shape consists of two circles, one with perimeter of 14 centimeters, diameter with 14 centimeter, and other one is with 35 centimeters. So we just have to calculate circumference of two circles, and then we can get the whole perimeter of the whole combined shape. So here I have shown the calculation how it is done. So there's another additional question they have asked. To cover this area, they are using for 1 meter it cost 5,000 rupees. So how much it will cost for the whole shape? So we have to calculate 154 by 5,000, and we can get the value easily. We can make this combined shape into two parts, that is two lines plus these two semicircles. Then we can get a full circle. So that here the value of the lengths are 20 plus 20 40, and for this a whole circle 2 pi r, r is 7. So from that we can get 84 meters. And there also another question, number of asking they are going to cover it with the tiles. So length of a tile is 25 centimeters. So how much tiles they may need? So 84 in meters, so how we to convert into centimeters, that is 84 centimeters divided by 25, that is 336 tiles we are needing. And then we go into the fourth question. So in the fourth question we have to calculate the length of the wire that needed. So we have to simply that one also can see. So here I am showing how simple it is to do the calculations if we see the correct picture. So we can see this is the same shape has repeated. So in these two cases, so we have to calculate only a perimeter of 1, then we have to multiply it by 2. So for this part we can see 2 pi r, the theta value is 60 degrees, so 60 over 360, and we have to add this 2 radius. So by that we can get by calculation, then we can show that perimeter is 128. So this is the first lesson. I think you understand it is a very simple, actually it's a very simple question. Only the new thing that we learn here is how to calculate the arc length and a perimeter of a sector. Then we can use it in how we can use it in complex shapes. So see you in our next video. Thank you.